So are you ready to dive into the series to learn what Python can do for you? I'm excited to start teaching you. Now the first thing that we have to do is we have to define what Python actually is, right? One of the important things when you start to learn technology is to make sure you're learning the thing that you actually think you're trying to learn. And so when we talk about Python, Python is a programming language. More importantly, it's what's called an interpreted programming language. So basically what we're going to be doing is we are going to be writing scripts in Python, using the Python language. We're going to be putting that onto our computer, our server, or our IoT device, and then we are going to use something called the Python interpreter to be able to run that script. Essentially what the interpreter does is it reads a script, turns that into whatever the finished product is, and then we get a web app, then we get a mobile app, then we get a desktop app, or whatever else. So basically the interpreter turns our text into the program itself. The reason that people are very interested in learning Python is because it's a very, very versatile language. Again, I come from the old school systems world. I got my MCSE back in NT 4.0 days, and so for me, I like to see how systems can connect together. I like to work with databases and operating systems and APIs and have numerous systems be able to communicate with other numerous systems and have AI do all kinds of fancy stuff. And one of the great things about Python is Python allows you to create solutions that do this. You can create everything from desktop applications to things like robots. This big thing here is actually a robot that runs off of Python. You can create server applications, AI applications, all kinds of different things. One of the things that I found quite interesting is many people that are learning Python actually are not even technology professionals. Many of them nowadays are scientists. So whether you're a scientist or maybe you're a salesperson or a marketing person, one of the issues we run into in the modern world is we have so much data. Right? We have all of these things creating so many data points, and so even if you're not a technology professional, many times you just have massive amounts of data that you're trying to figure out what to do with. One of the amazing things about Python is you can create scripts that very quickly are able to go through, look and analyze the data that you provide to try to give you the insights that you might be interested in. So Python is an interpreted language that allows you to do a lot of things, and I think you're going to find this whole program to be very, very interesting. Now the first thing to talk about when we start talking about Python is just to keep in mind the versions of Python. Now hopefully you will only be dealing with version 3 and you won't run into any major problems with version 2. But again, legacy systems have a nasty habit of not dying when they're supposed to, so you might run into a version 2 out in the world. So there was a version 1 of Python back in the 1990s. In the 2000s there was version 2, and now we're dealing with version 3. Basically, the important thing to understand is that there are massive differences between version 2 and version 3 of Python, and they're not interoperable. If you have a version 2 interpreter on your system and you try to run a script that was written for version 3, it will not work. If you have a version 3 interpreter on the system and have a code that was written for version 2 trying to run, it will not work. These are very much essentially different programming languages. Again, for the most part, you shouldn't run into major issues except, you know, we're in the tech world, so things happen, right? So version 2 was supposed to die somewhere around 2010. I think it was either 2010 or 2012. That was supposed to be the end of life. And, you know, as things go, people kept using version 2 past the end of life, and so they kept extending out the end of life all the way out to 2020. So again, all the way up into 2019 and 2020, you still have people coding in Python 2. So you might actually run into that code in the real world. One of the important things to understand between version 2 and version 3 is, again, Python is an interpreted language. So the interpreter is actually a program itself. So when you run the interpreter, it does whatever it's doing when it reads the script. And so that was one of the things that they found, is that there are just too many security bugs, there are too many efficiency problems with version 2, and so that's why they wanted to go to version 3. So if you are running a version 2 software on your systems, realize there may be some actual security issues there, and since the interpreter is no longer being updated, you might run into some nasty hacking things going into the future. Now for most people, if you're going to be learning Python nowadays, again, this probably won't won't run into any issues, again, unless you run into legacy systems, but you might run into problems if you decide to do something such as go to Amazon.com to buy like a Python for Dummies book. I actually purchased a Python for Dummies book for building Raspberry Pi projects a number of years ago, and when I got the book in the mail, it was actually for version 2, so it was basically worthless. So if you are going to go out there and buy books about Python, do make sure you're going to buy them for version 3. Now, when you start using version 3 of Python, there have been multiple updates to version 3 as time has gone by. I think we're at version 3.12.3 at this point. Now, for the most part, this shouldn't cause you any major issues, right? If you have code that you wrote for 3.8 and you have a 3.12 interpreter, it should be fine. If you have a 3.8 interpreter and you wrote it for 3.12, more or less it should be fine, except if you run into certain circumstances with certain frameworks. So we'll talk about frameworks in a little bit. Basically, frameworks are libraries of code that allow you to extend the capabilities of Python, and so sometimes with those libraries of code, they will require that you have at least version 3.10, or that you'll have a version 3.12, something like that. So there are differences between these versions of Python 3 Linux, but they shouldn't be massively significant. You should just kind of keep that in mind. So version 2 of Python, do not touch unless you are required to. Version 3 is where we're at. So the next question is going to be, what can you run Python on? So as far as operating systems are concerned, you should be able to run Python on darn near anything, right? It'll run on Windows, it'll run on Windows Server, it'll run on all of the Linux flavors that are out there, it'll run on Mac OS, and it'll even run on many vendor-specific OSs. So as far as operating systems are concerned, you should be fine as far as whether or not Python will be able to run on it. Then we start talking about things like hardware requirements. And the great thing about Python too, especially when you're first learning Python, you're interacting with the operating system, you're interacting with databases and APIs. The fact of the matter is you don't need much hardware at all to be able to run Python. So this is one of the lab computers I had when we were doing the in-person Silicon Dojo classes. This is a 2012 MacBook Pro, so whenever you're watching this, somewhere between 13 to more years old at this point. Basically, I put Ubuntu on here. It has a solid-state drive, and it works really well for doing Python classes. I'm not just saying you can learn Python on this, I'm saying you can and you literally run into no issues. For basically stock standard Python, this is absolutely great. Along those lines, again, if you have something like a Raspberry Pi, this is a Raspberry Pi 4, Python works great on a Raspberry Pi 4, and as long as you know what you're doing, because it requires command line and a whole bunch of other things, Python works fine on one of these little Pi Zeros. So this is like a 1 gigahertz processor with 512 megs of RAM. So literally almost any computer you have, in the 2020s is going to be better than this. The one warning that I will give you though, and this is one of the things you have to be thinking about whenever you're using something like Python, is that there's Python and there's going to be those frameworks. Again, we're going to be talking about frameworks in a few minutes. But frameworks basically extend the capabilities of what Python is able to do, create web apps, add computer vision, add artificial intelligence services, those types of things. And so Python doesn't need like any requirements, right? You can basically run it on what we call a potato and you'll be fine. The thing is like once you start doing things like artificial intelligence, that's when you might need a lot of resources. So again, with this 2012 MacBook Pro, Python runs perfectly fine on here. There's a LLM framework called Ollama that it works. I will say Ollama works. Not amazingly well. And so that's going to be one of the things you need to be thinking about whenever you're going to be, speccing out the system that you're going to be using either for your projects or putting something into production, is thinking about the overall tech stack and not just simply what Python will need, but what all the other components in the tech stack will require. I will remind you, if you don't know, there is something called API. So an API call is when your script calls out to somebody else's services. So if you want to send an SMS message, you do an API call to a company called Twilio. If you want to be able to send out emails, you do an API call to a company called SendGrid. If you want to do AI services, OpenAI has an API. So your little script communicates with OpenAI. OpenAI then sends you back the response. One of the important things to understand there is all of the resources that are required, even for something like an AI service, that's all being done on their systems. So, right, you could have a really, really crappy computer that's running your Python code. It makes an API call. All the resource requirements are on the API server systems. You just get a response back. So if you're going to be doing things like OpenAI, you don't need a very powerful computer. This is one of those things to consider. Again, when you're building out your architecture, you're building out your systems, is basically where are the services going to live, as we say. And basically what we mean, is it going to live on your computer, or is it going to be something like an API call? And that's one of the things you have to think about with speccing your system, is if it's going to be running. So Ollama runs locally on your system. So if it's running locally on the system, you need to buy the resources. You need to have the resources to allow it to work. If it's running somewhere else on an API call, then you can have a really crappy computer because it doesn't matter, because all the resources are being used by those API servers. So that's one of the things to be thinking about with Python. But basically, the great thing with Python, especially as you're learning, is just go find some crappy computer that has some dust on it, throw Ubuntu onto it, and you should be fine for basically all the classes in this particular series. Now, one of the cool things about Python is Python can directly interact with the underlying operating system that it's installed on, right? So basically, if you have a script and it's running on an Ubuntu Linux system, your script can actually communicate with the Ubuntu Linux operating system and be able to run commands and get responses from those commands. So one of the big things a lot of new coders try to figure out, they're like, oh, how am I going to build X, Y, or Z? And one of the most important things to remember is, coders are supposed to be lazy, so we don't want to build anything we don't have to build. If somebody already created a command line tool previously, I don't want to build a new command line tool. I just want to run that command line tool from Python, get the response back, and then do something based off of that. So one of the great things about Python is you can actually run commands directly against the operating system that it's installed on to do any number of things, right? So if you want to do a ping, you want to do some kind of like a network scanner type application, you can actually just run the ping command directly from Python, get the response back, and then do something based off of that response. If you're going to be doing network scanning, if you're going to be doing things like cybersecurity or hacking, right? There's a piece of software called NMAP, which is a command line network scanning utility. You can actually run that directly from Python, get all the results back, and then do whatever it is that you want to do. So one of the great things about Python is you get all the power of those underlying command line tools that you can then bring those resources basically into your script. One of the things to remember, though, is depending on the operating system, you may have different command line utilities you can have access to, right? So Linux, right? Linux is the open source operating system people have been using for decades at this point. So there are a crap ton of command line tools that you can use on Linux. If you go over to the Mac OS world, they have a lot of command line tools, but you might have to use something called Homebrew to be able to install additional Linux command line tools onto your Mac. And that's a level of troubleshooting things that you'll have to figure out. If you go over to the Windows world, right? Windows has a lot of command line tools too, but again, that's its own world, and how it deals with command line is its own thing that you're going to have to think about. And so one of the great things about Python is you're able to interact with the operating system, but you do have to be thinking about what is it that you're actually trying to accomplish and which operating system will solve your problems in the easiest way going forward. Another one of the great things about Python is it basically connects to darn near every database out there. Now, I have been a technology professional for almost 30 years, so I'm not going to say it connects to all databases, because obviously that would probably be incorrect, but basically almost any database that you're going to want to be able to connect to, Python is going to be able to connect to it. Do you want to connect to a NoSQL database? Do you want to connect to a relational database? Do you want to connect to Postgres or SQLite or any of these other databases that are out there? One of the great things about Python is it should be able to interact with those databases, and you shouldn't have any major problems. And so this is great, especially depending on what kind of environment you're in, or depending on what kind of projects you're able to create. However you want to be able to store your data, you should be able to find a solution with Python that'll work out okay for you. Now, as I've talked about previously, one of the real powers of Python is its ability to communicate with APIs. So there was a programming language called PHP that was the bee's knees all the way up until about 2010. So when everybody owned their own systems, right? So when I owned my own server, I owned my own MySQL database, I owned my own email server that was all within my infrastructure, there was a programming language called PHP that a lot of people liked to use at the time because it allowed you to interact with all of these systems that you actually had control over. Well, then we got to the world of something called service-oriented architecture. And the idea being is, why do you want to worry about updates on your system? Why do you want to worry about whether a CPU fan in your server fails? Why don't you just kind of rent services from somebody else, right? Instead of running your own email server, why don't you use an email API that simply allows you to connect to somebody else's service to be able to send out an email or get it back, right? If you're going to send out SMS messages, again, use a company like Twilio to be able to send out SMS messages, those types of things. And so the interesting thing is about 2010, when this service-oriented architecture was really taking off and all these APIs came out, the vendors for these different APIs basically decided that they were going to support Python and they were going to support JavaScript, and they weren't going to support many other programming languages, right? And so that's one of the reasons that Python really took off, because if you wanted to use any of these really cool fancy features, basically you simply had to use Python in order to use those fancy features. And so one of the great things with Python is there's a tremendous amount of services out there that basically all you have to do is something called an API call. We're going to have classes on this in the future, but basically you just write a little, you could 2, 3, maybe 5 lines of code, and in those 5 lines of code, that gives you access to all the power of somebody else's systems. One of the buzzwords, buzz phrases that I say is AI is hard. And I tell you, AI is hard, but APIs are not, right? Trying to understand how OpenAI does whatever it is that OpenAI does, right? That's going to take a lot of brain power. For you to use an API call with Python to be able to communicate with an OpenAI server, be able to send it a request and get a response back, again, that's going to take you about 10 lines of code, right? The API call is incredibly easy. So that's one of the great things about Python, is it allows you to be able to do these API calls, which allows you to bring in the power and the resources of these external systems and actually be able to use it in your Python script relatively easily. Now, the final thing to get your head around when you start thinking about like what is Python is the idea of frameworks, right? And so basically what frameworks are is they're libraries of code that allow you to extend the capabilities of the core Python language. Again, remember, if you're going to be a coder, copy and paste is your friend, right? If somebody else already solved the problem, there's no reason to re-solve the problem somebody else solved, right? So if somebody figured out how to turn Python into a web app platform, why rewrite something that somebody else has basically already created, right? If somebody has figured out how to use Python in order to do computer vision or something like that, why rewrite that? Basically just use somebody else's code, bring that into your project, and away you go. And that's what we're talking about when we're talking about frameworks. So there's frameworks for things like web apps. So when we talk about things like web apps, this might be something like Instagram, right? Instagram, originally at least, was built on something called the Django framework. So they used Python, they used a Django web app framework, and they built Instagram, got it to be worth $1 billion, and who knows what it's worth now. So that's one of the things to be thinking about when you're like, well, I don't know if Python and these frameworks are up to what my organization needs. It's like, do you think your organization is going to be worth $1 billion? If not, Python and Django will be fine for you. But anyways, there's different web app frameworks out there. Django is a framework that allows you to be able to create a fully fleshed social media sites if you want to. There's another web app framework called Flask that allows you to create small little web applications. And here for Silicon Dojo, we use the web app framework called Bottle a lot, just because it's incredibly simple to use. And again, it allows you to use Python to create web applications, again, to solve any types types of problems that you want to solve. If you're going to do something like GUI, desktop applications, you want a graphical user interface, right? You want to be able to right click and left click, and you want buttons and that kind of stuff. There is actually a framework in Python that allows you to do it. There's a framework called tkinter. There's actually a couple of other frameworks out there too. And basically, simply, sitting there and typing out code, you can actually, with your text, create code that will create buttons and opens and submits and all that kind of stuff, and you can get a nice graphical user interface from something like the tkinter framework. There's a framework called Kivy that actually allows you to create mobile applications. Now, I'll be clear with that, you probably want to use like React Native or Flutter if you're going to be creating mobile applications, but the important thing to understand is that Kivy does in fact exist. And then you have other frameworks. One of the things we use a lot here at Silicon Dojo is something called OpenCV, so Open Computer Vision. This is literally a framework for computer vision. So it's a whole bunch of very, very sophisticated coding that we don't need to know much about. We install it onto our system, we modify the code where we need to modify the code, and now all of a sudden we are using Python and computer vision to be able to build things like robots. So I don't know if you've ever seen this. I do videos about this little guy every once in a while. This is my Louis Rossmann attack robot. So I literally have a picture of Louis Rossmann, and if I put it in front of this whole robot will go and try to attack Louis Rossmann. And the way it's able to do that is it uses OpenCV for computer vision and then a whole bunch of other stuff in order to make it run. So this is what frameworks do and why they're so important. And it's also important to understand if you're going to be building Python projects that the entire project will be Python, but most likely you're going to need to use some of these frameworks in order to be able to extend out the capabilities to actually fully solve whatever problem is that you're trying to solve. The one warning that I will give you with frameworks, and I ran into this when I was learning Python back in the day, is that I thought learning Python was going to be hard, and then learning frameworks was going to be easy, right? I gave myself like a month for Python, and then I gave myself like 3 days for some of these frameworks. What I will tell you in all seriousness is many times the frameworks are far more difficult to learn and master than Python itself. Python you can more or less learn in a week. Some of these frameworks might take a month or more, and so that is just one of those things to keep in mind. So now that you understand why Python is important, basically more or less what you need in order to run Python, you understand a little bit about APIs and frameworks and those types of things, you are ready to start learning Python so that hopefully we can get you out there to solve the problems that you actually care about. So I think the rest of the series will be very fun and interesting, and I look forward to teaching you.